Geology is the study of the Earth's crust, the rocks from which it is composed, and the processes by which they undergo change. Geology may be used as a means to study the history of the Earth, its past climates, and the evolutionary history of life. Closely related to geology is the field of geography, which describes the Earth and all of its physical and human complexities. Geography describes the oceans, land, mountains, valleys, rivers, lakes, and other distinguishable features of the Earth's surface. The domain of geology is the Earth's usable crust, loosely interpreted as the layer on the surface about 10 kilometers thick. While it is recognized that certain geologic processes, including tectonism and volcanism, may have their source at greater depths, the 10-kilometer limit is significant because it represents the crust of weathering, where an active interaction of geology with groundwater is taking place. Over the past century, developed human societies have become increasingly reliant on groundwater. Geology studies the various types of rocks on the Earth's surface, including igneous, sedimentary, and metamorphic, and the information that can be weaned from geologic history for the benefit of humankind. Geology interacts with the climate and fundamental laws of physics and chemistry to produce an Earth that, while smooth and round when observed from space, may appear rough or irregular when viewed at close range. A simple calculation will serve to illustrate the dichotomy. The highest point on the Earth's surface is the peak of Mount Everest, which straddles the countries of Nepal and China. Its peak is at an altitude of 8,848 meters. On the other hand, the Earth's circumference, measured at the equator, is 40,075 kilometers long. On a per-quadrant basis, the maximum relative roughness of the Earth's surface, excluding the depth of the oceans, is indeed quite small. Yet, anybody that has climbed Mount Everest will attest to the challenge. On the other extreme, there are portions of the Earth's surface that are extremely flat. For instance, the Uyuni Salt Flat in southwest Bolivia, the world's largest, encompassing 10,582 square kilometers of surface area. The salt lake, covered with a few meters of salt crust, is of extraordinary flatness, featuring elevation variations of less than 1 meter over the entire area of the lake. Geographically, Uyuni lies at the terminus of the large endorheic altiplano basin of Peru and Bolivia, collecting the salts that originate in the basin of Lake Titicaca and those of other lakes in the region. Uyuni's flatness conveys a message of extensive subsidence and sedimentation, and, geologically speaking, of time gone by. The source of all salt is rock weathering, yet the fate of salt is double-pronged. In exorheic basins, it winds up in the ocean. In endorheic basins, it collects in salt lakes and, in extreme cases, in salt flats such as Uyuni. Geology by itself does not explain all processes on the surface of the Earth. Other factors include atmospheric and oceanic circulation, tectonism, volcanic activity, continental location, latitude, and, given the relative smoothness of the Earth, the form of the surface. All of these factors have a role in determining the character of the processes. Geology is only the first of a chain of related processes that condition and make possible life on Earth. Geomorphology may well be the second.